So now I'm on slide 7. Jack and Emily are selling candy. Jack bought his box of candy for $25 and is selling each piece of candy for $3. Write an equation in the box below to represent Jack's income. So this is a linear modeling problem like we saw before Thanksgiving break. So I know that I'm going to have to use y equals mx plus b somehow. I need to find what my m is, or my rate, or my slope. They all mean the same thing. And I need to find what b is, which is my starting point. So if I'm looking, he bought his box of candy for $25. So that's his initial fee. He pays that one time. He pays $25 one time. And he's selling each piece of candy for $3. So I know that every time he sells his candy, he gets $3. So if I'm thinking of what's more of my starting point versus what's more of my rate or my slope, I know he has a $25 one-time starting fee. But then he's going to make $3 every time he sells a candy bar, which is going to happen more often. So I know that my M value has to be 3. That's my rate. He earns $3 per candy bar or piece of candy he sells. And then the starting point is going to be 25 since he paid that $25 initially. But when he first bought this box of candy, he had to pay somebody $25 and he was not making any money yet. So this is going to have to be a negative 25 to represent he was paying someone for the candy versus selling the candy. He's not earning money off of it yet. So my equation is going to be y equals m is 3x minus 25. That's my equation for Jack. And then if I scroll down now to number 8, I see that we have a similar situation. Emily bought a box of candy for $45 and is selling each piece of candy for $5. Write an equation in the box below to represent Emily's income. So again, I know I have to use y equals mx plus b, and I need to figure out what m is, and I need to figure out what b is. So similar situation, she bought a box of candy for $45 and is selling each piece of candy for $5. So she earns $5 per piece of candy that she sells. Just like with Jack, I know that's going to have to be my slope because every time she sells a candy bar, she earns $5. And then the starting point is going to be something about this $45 because she paid this one time, and then everything else after that is going to be her earning money selling the candy. So I know my starting point is going to be $45, but just like with Jack, this is going to have to be a negative because she had to spend that money. She had to pay somebody else $45 to get the box of candy. This 5 is positive because she's earning $5 each time she sells a candy bar. So make sure we know the difference between those two, why one's positive, why one's negative. If you are still confused, pause the video and ask me in class or email me if you are outside of class hours. So now I'm just going to fill in my m and my b. So m is 5x and then minus 45 for my b value. So this is Emily's equation. Now if I go to slide 9 here, the first step is telling me to graph Jack and Emily's equation in Desmos. So if you don't have your graphing calculator open, go ahead and open it. I am going to copy Jack's equation here. Oh no, it didn't go. So I'm going to type Jack's equation, 3x minus 25. And if you need to pause the video to do this, please do so. And then I'm going to graph Emily's equation, y equals 5x minus 45. Perfect. So you might have to scroll over a little bit to see these graphs. You might have to zoom out a little bit. Just play around until you can see where the two graphs meet and that you have a good view of these two graphs. So this next question, number 2, is asking, at what point do these graphs intersect? Well, if you zoom in, we found that they intersect at the point 10, 5. So So I'll type that in the box below, 10, 5. And question 3 is asking, what does X mean in the context of this problem? So I'm going to go back and I'm just going to look at Emily's equation here to figure out what X means. X is going to mean the same thing for Jack and the same thing for Emily. Keeping in mind that Y tells me a total amount of something, a total amount of hours, a total amount of weight. In this case, because we're dealing with money, Y tells me the total amount of money. So when I put these two pieces together, I'm going to find out how much Emily made selling her candy bars. So I need to think, if Y equals an amount of money, a total amount of money, what does X equal? Now, X is a number that can change in the problem. And if I'm looking to see what can change, this $45 for her initial fee, that doesn't change. That's just one time. She makes $5 for each piece of candy that she sells. That doesn't change. But the number of candy bars that she sells can change. So X is going to tell me how many candy bars she sells. Usually X tells us how many of something, how many hours, how many candy bars, how many marbles, whatever your problem might be asking for. X is going to tell you how many. So I'll come back here and paste this, that X is going to tell me how many candy bars she sells. So now we're done with slides 7, 8, and 9.